Assalamualaikum and good afternoon. Can you hear me? Anybody can respond?
Yes, Doctor.
Yes, doctor.
Okay, can you see the file that I shared?
Yes,
Yes,
Doctor.
doctor.
Okay, thank you. Thank you for the response. Okay, so I think we can start our briefing on the mini project. Okay, so I hope all of you have gone through the document. Okay, because that's the reason why we have this briefing today is basically if you have any general issue with the document that you can let us know today in the session that we have today. So basically I don't intend to give a very detailed briefing on the project. So basically just to touch several things which we need to highlight. Okay, so basically if you refer to the project, if you still remember, basically the problem is exactly the same as the one that you did for mass balance, right? So it is exactly the same problem. Eh? So last time you only need to perform mass balance calculation, right? And but since now you already learned about energy balance, so you now you need to include energy balance as well. Okay, so this is a team project. Okay, so this is a team project. So you need to work with your own team. Okay. So what I would like you to I want you to what you call it? You need to assume that you are in a competition. You need to assume that you are in a competition with other teams. So basically, other teams doesn't matter whether it is in your section or from other section are your competitor. So meaning that you cannot like share information or whatever. Eh? Uh, right. So because you don't do that with your competitors, right? So what I'm trying to say is that I just want you to discuss within your team. Okay, so that all the team members can participate in solving the problem. Because if you discuss with other teams, then your team would not be efficient, right? So that is what I want you to think. Uh, you need to assume that your other teams are your competitors, so you don't share information. Okay, try to discuss within your team in terms of how to solve the problem. Okay, so there's a reason why your team must be only between 3 to 4. Okay, I hope there are no teams with 5 members. Okay, maximum team members must only be 4, minimum 3. Okay, so that it is efficient for you to work on the project. Okay. All right, so that is on the definition of team mini project. A team, so you need to work in your team, and in order to make sure that you work in your team, I think maybe I will discuss with other lecturers. Maybe we will try to impose auto rating. Auto rating. So it means that if you don't contribute as a team member, then you would get a low peer auto rating, then you get lower group team project marks lah compared to your team members. That's the first thing on the definition of team. And then in terms of the duration, so you are given around more or less 3 weeks. Okay, so basically we have published the document yesterday, right? And then the deadline is 23rd of January. So you have more or less 3 weeks. Okay, so you have 3 weeks. So normally, from my previous experience, normally students basically will only start work on it in the third week, which I don't want that to be happening. Okay, so you need to work from now on. Okay, so that is why even though you have 3 weeks, we only allow you to ask question in the first 2 weeks. If any problems that you have, you can ask this week, you can ask next week. But in the third week, we will not entertain any question. Eh? Right? So you in this first 2 week, you need to go through it, make a draft of what you want to do, and how you would solve the problem. Okay, so the question only the first 2 weeks. Okay, last week you focus on solving the problem lah, right? So we will not entertain any question. If you ask question in the third week, then I will ask all the lecturer to penalize. We will deduct marks if you ask question in the third week. Okay, so this is just so that you will work early on, and that's the reason why we impose that rule. Okay, so in terms of the details, all are the same. Of course, I understand that there are also some of you who were not in the last semester's mass balance class, right? Maybe you are direct entry, or maybe you because we also have diploma students, right? Direct entry, so they managed to get transfer credit for mass balance, so they directly get took energy balance. So for those students, of course, this might be new for you lah, but of course, in your team, they must be at least two of the student who have gone through the mini project last semester on mass balance. So for those who have gone through mass balance last semester, so of course this would be familiar to you, right? All these are the same, exactly the same. So I would like to focus on the instruction. Okay, instruction number 1 is just the same like last semester. Okay, number 2, so this one you need to pay attention. So it says here, do not reuse the project output from last semester. Because you already did the mass balance calculation, right? So you might as well just use it, right? You can, maybe you think, of course, everybody will think like that, right? So but what I would like you to do is that I would like you to redo it, because there are many reasons. Because your teams are different, that is one thing, and then from my previous from what I seen last semester, your answers are also different. They are not the same, maybe slightly different, maybe different here and there. So it's not the same, right? So because it is quite a big diagram, flow diagram, right? So we have differences in certain places, maybe due to certain reason, maybe due to the accuracy of the calculation, I'm not sure. Okay, so what I would like you to do is actually I will like you to redo it, redo everything. So I have all the files from last semester, so I hope you don't just copy from what you have. Okay, you need to rediscuss your team members, and try to come up with your new team's flow diagram and everything. But since you already have the file last year, of course it should be faster this year because you already done it before. Okay, so that is one thing that I would like to highlight. So you need to redo what you have done last semester, especially on drawing the process flow diagram, and also the mass balance calculation. Okay, and then number 3 is the same as before. Number 4 is, okay, number 4 we just add energy balance. Solve mass. Yes, last semester solve the mass balance, unknown for this process, but now we have solve the mass and energy balance. Okay, so basically what we have added in the table, we have table 1, right? If you can refer to your table 1. So if you refer to table 1, the difference between mass balance and energy balance mini project is that we have added one column, this one, which is the total enthalpy of each of the stream appearing in the process. So basically you need to calculate the enthalpies of each of the stream, okay, which you already have done it in your class, right? You have this enthalpy inlet outlet table, and then you have reference state, and then you have unknowns in the table. Then of course you need to calculate the unknowns using by drawing hypopath and everything. Then of course at the end you calculate the enthalpy. So basically that is what you need to do in this project. So basically you need to calculate the enthalpies of each of the stream appearing in your diagram. Okay, that is number 4. So basically you calculate all the enthalpies, and then And from number 5 to number 8, so these are some questions that you need to answer lah. And for example, number 5, calculate the amount of power release absorbed, state which in the oxidative reactor and neutralization reactor. B, amount of heat requirement in the extraction column, and so on. Basically, all these are related to energy balance questions lah. 5 to 8. Right, and then okay, number 9 says here when solving the energy balance problem for the reactor, use the heat of formation method. Okay, so it is clearly stated here that if you have that you need to use the heat of formation method for the reactor lah. Okay, and I would like you to think if you are using heat of formation method, then you would be using the elements, right, as the reference state. So then for the non-reactive process, what should be the reference state? So that thing maybe you can try to think, and that would be some of the popular question lah, in terms of the reference state. Okay, so number 9, so I just would like you to focus on this method, which you need to use, which is the heat of formation method. And then number 10 is the same as before. You need to have in your Excel, there must be one sheet containing the overall process, and then the table, and then you need to have respective sheets for each equipment, and then you must make sure that the values in different streams are interconnected between each other. The idea is that if you, let's say, you need to change the basis, okay, of course in every process there must be a basis. If you need to develop your Excel file so that if, for example, you need to change the basis of the process, then all calculation will follow accordingly. Okay, that is one thing that you need to make sure lah. And okay, and then number 12, so apart from the Excel file, you need to prepare 2 short report containing the details step by step. Yeah, I would suggest you just write this in point form, because you need to write the steps, the detailed steps. So you need to be clear the first step, the second step, the third step, and so on. Okay, and then okay, so in terms of the submission, of course you need to submit both Excel and Word or PDF file. Okay, you need to submit it to your respective lecturers. Okay, you need to ask them, okay, how to submit, whether through email or through the e-learning page. Okay, so the deadline is 23rd of January 2021 before midnight. Okay, so no extension will be provided. 3 weeks is fixed, no extension will be provided. Okay, number 14, okay, this one I already mentioned about the team. And number 15, this is the rubrics, which is exactly also the same as like last year. My process flow diagram, 3%. So draw it very neatly, very clear. Data interconnection, make sure that all there are connections between the streams. 2%, report 2%, answers 3%. So yeah. And what else? Okay. All right. So for your project, for this mini project, the person in charge is actually Dr. Jama Rosliza. Dr. Jama ada ke dalam ni? Dr. Jama, are you there?
Ada dia.
Ada ya. So PIC untuk for the person in charge for the project is Dr. Jama Rosliza. But I would suggest, if you have any question, you can ask your lecturer, your respective lecturers first. If they couldn't provide the information needed, then you can ask Dr. Jama lah. And ada apa-apa lagi tak Dr. Jama nak tambah?
Dia dah itu je kot. Dia lebih kurang sama je.
Yes.
Macam mass balance tu. Actually, for the energy balance is much more simpler compared to the mass balance to solve the mass balance problem. I think maybe there's no problem.
Okay. So now I open for question. If you have any question?
Doctor,
Yeah.
I want to ask the reference state for this project can only have one reference state for each compounds or every single unit can have one reference state.
Okay, I leave that for you to think first. Can I do that? Okay, boleh tak, Chiu? I will leave that for you to think first. I would like you to think the logicness of what you were that you will do, the logicness. Huh? Of course you can. Of course you. Logic. Well. Of course you can. Of course you can have different references for different unit. But is it convenient? Something like that. Is it? Right? So it's something that you can think about. The important thing is that you understand what's the function of reference state. If you understand the function of reference state, then you'll be able to come up with an answer lah for that. Okay, because this is still day one, guys. So I will leave it up to you to think about it.
Okay.
If you cannot still find the answer, just let me know after in week 2. Okay,
Okay.
there we can discuss about that. Okay. Other question? I'm not sure about other lecturers. For my section, mini project will contribute 15% of your marks, because mini project 10%. For my class, another 5% I will allocate for presentation. Yeah, you need to present the findings that you get from the project. I will give marks 5%. That will cover under CTPS, critical thinking, problem solving. Okay, basically I will be focusing on the problem solving. How do you solve the problems? So that I will provide marks, and that would be individual marks lah. So meaning that each team member must present during. That is for my class. I'm not sure for other class. Maybe the lecturers can say something, or maybe they will inform you guys in your classes lah. But for my class, it will be 15% total, so it's quite significant lah. Quite significant. 15% is quite a lot. Okay, anything else? Nobody want to argue why do we need to redo? Tak kisah kan? Tak kisah tak apalah. Ada apa-apa lagi tak? So basically itu sajalah some of the things that I would like to highlight. Dari segi detail you discuss sendiri lah. So tak ada no other question?
Doctor, for the total enthalpy, is that the Q, because we always calculate is the Q equals to in out minus in. So the total enthalpy is for the one stream at the temperature or the out minus in.
Okay, alright. Okay, good question. So basically, if you refer to this table, so this is table 1, right? So I'm sure you still remember this table. Okay, we have the first column, we have stream number, right? All right, stream number, we have 1, 2, 3. So all these numbers represent stream, right? So if you refer to the bottom part, under the energy data part, okay, basically what you need to do through energy balance, you can calculate the entropy, right? So this total entropy means the total entropy of the stream. It's like for chapter 9, right? So you in or maybe chapter 8 as well. In one of the steps is that you need to draw the inlet outlet entropy table.
Yeah.
You have the inlet outlet entropy table, right? Whereby you have the in amount and in specific entropy, and then you have the output amount and also the enthalpy, specific enthalpy, right? So basically, what you need to calculate here is the same as what you need to do when you do that part, when you need to calculate the specific enthalpy in that table. Okay, you have H1, H2, H3, and so on. All those are unknowns, right? Specific enthalpy unknowns in that inlet outlet enthalpy table, right? So basically, it's just the same what you need to do here. It's only that the unit now is in kilowatt. So it's not a specific value. So you need to multiply the specific enthalpy that you get in this table with the mass lah, with the amount that you get here in the mass flow rate, for example. Then only you will get the total enthalpy in kilowatt. Nothing to do with Q. Nothing to do with Q. Q is Q. Q is one term of the energy balance equation. If you have an open system, delta H is another term, right? You have enthalpy. So when you talk about in out, it's nothing related with in or out. It's related with the stream. For example, this unknown is with respect to stream number 1. This unknown is with respect to stream number 3. So it is that for that particular stream. If you refer to this question, question 5 to I think. If you refer to this question 5 until question 8, for example, then only you need to calculate the difference, right? In, out, or whatever. We are talking about the unit now, because if you refer 5 to 8, we are talking about the unit, not the stream, right? So Q in and Q out is based on the unit. Betul tak? If you have a heater, then Q in is Q in to the heater, not into the stream. Right? Okay. So you need to understand that. 5 to 8, then only you need to calculate Q. If I'm not mistaken, you can go through lah, Q. But in the table, you need to calculate enthalpy, H, the unknown enthalpies. Okay. So since you asked that, I would like you to highlight that your source is not only Felder. Source of data, you don't restrict yourself only Felder. You can use whatever sources that you can get from other literature, from internet. You can get from whatever source. Like for example, CP, you might need the CP value, you might need the standard heat of formation, right? Standard heat of apa lagi? Heat of combustion. Maybe not all the compounds here you can get it from table B1, for example, right? So then you can just refer to whatever source. Okay, ada lagi soalan? Any question?
Doctor, I have a question.
Yep.
For the mass balance, do we need to specify the detailed steps for the mass balance as well, or just do mass balance calculations for the report?
Oh, report. No need. For me lah. Kalau Dr. Jamal nak lain beritahu sebab because last time for mass balance saya yang marking, but now energy balance Dr. Jamal yang marking. Tapi kalau saya dulu, kalau Dr. Jamal nak kekalkan, for the report, I just want you to write the steps. Not detail step. Okay, memanglah detail step, tapi detail step tu is for the whole project.
Saya pun ikut jugalah macam tu.
It's not like when you need to do mass balance and then you kata kena ada basis and need to apa row diagram completely. No, benda tu tak payah. I just want to know the steps. Detail step here is written here, detail step. Why? Because of course the mini project is considered big, kan? Of course there are many small steps that you go through in order for you to get the final answer. Okay, of course from your Excel file, then I would see lah the detail that you include in terms of whether mass balance calculation or energy balance lah. Put everything in Excel lah. I mean in terms of the detail calculation and everything. Okay, so for report senang je. It's just you can do it by bullet point and then just cerita. Okay, first step you buat apa, next second step you buat apa, next you buat apa, itu je. Very general lah, very general. Just because just want to see lah. We just want to see the steps that you have taken lah, in order to solve the problem from start until the end. But not detail, because it's just 2 page. 2 page is not that much kan. Okay, any other question? Ada lagi tak?
Doctor, is it we assume the mixer is adiabatic?
Depend on the description. If it says so, then adiabatic lah. If it says there's heat in, heat out, then there's heat in, heat out. Because some mixer they have heat in kan. Some mixer don't have any heating. So it depends. But normally of course in our class pun kita banyak assume adiabatic lah. Tapi it depends on the question. If it doesn't say adiabatic, if it need to be adiabatic, you can add the assumption lah. If let's say there's no info on the heating ke apa, then you pun tak diberitahu whether it's adiabatic or not. Then just to be safe, you tulis je lah. Assume adiabatic kan. Setakat ni Ciu, Imran dengan Gan, hebat lah. Hebat. Apa ni, section 2 hebat. Mana section lain ni? Ada soalan? Tak ada? Dr. Jamak tambah apa-apa? Kita tamat ni.
Tak ada dah kot.
Okay, so kalau tak ada, if there's nothing else, so please remember you have 2 weeks to ask any question. Okay, and week 3 you need to focus on solving the problem. Alright, so thank you very much for your time today, and all the best for the mini project. And thank you very much. Thank you.